Hey guys, we're going to finish our workbook here. Okay, so using your card, make sure you look up your definitions of each of these on your flashcards and read through this and try to answer these questions without me and make sure that you double check your answers here. All right, so our first example says, the time it takes a fifth grader to complete a particular math problem is normally distributed with a mean and standard deviation given. Find the probability that a random ninth grader will take more than 2.5 minutes to complete. Now, I didn't see the word average, so this is just my normal population distribution. Okay, so that my mean is 2, and my standard deviation is 0.8, and so what would be the probability it would take more than 2.5 minutes to complete? So this would be normal, CDF, with my lower bound, upper bound, mean, and standard deviation. Lower bound is 2.5, upper bound would be a really big number. Mean is 2 and standard deviation there. Notice I didn't divide it by the square root of n because I'm not taking a sample here. This is my population distribution, not my sampling distribution. So I want 2, 0.8, and 2.5. So I want 2, 0.8, and 2.5. All right, so that kind of matches our picture, 0.266. So what's my probability that my value is greater than 2.5? And I already forgot it, 0.266. All right. Now, what do we got here? Suppose, just double checking my answer that I got the same answer as I got before when I did this. Yeah, okay. Suppose you give the problem a simple random sample of 20. Sketch the sampling distribution using the distribution to determine. So we know this was normally distributed, so this sampling distribution will be approximately normal, or actually normally distributed, right? Use this distribution to determine the probability of the mean to complete the problem of students greater than. And so really this is exactly the same problem, but instead of putting 0.08, I'm going to put sigma of x bar, which would be 0.08 divided by the square root of 20. So just kind of getting that in a calculator here. .8. All right, so 0.17889. So 2, and we still want the same answer. What would it be? So this is going to be much lower probability. 0.17889. So everything else is the same, but my standard deviation is 0.17889. Run my calculator here. Yeah, way out, because my variability is a lot skinnier there. Yeah. Okay, so I get 0.0026. So that probability of my x bar being greater than 2.5 is 0.00. Forgot my number. 0.0026. Nice. All right. Is this my last question? Yeah, okay. Last question. Using, I'm assuming because they had you review the central limit theorem, this would apply. So this question states the blood cholesterol of adult men has a mean, so the mean is provided, and a standard deviation is provided. An SRS, so simple random sample, so this is our N of 250 men, is selected. And we don't have a problem with our 10% rule because this is a big population, right? Lots of adult men. So we should be fine there, right? Sketch a sampling distribution of X bar such and calculate the probability. So the mean would stay the same and our sampling or our standard deviation of our sample would be 41 divided by the square root of 250. So let's go ahead and do that. Square root of 250. You get 2.593. Okay, so 2.593. And what are the chances it's greater than 193? So 193 is my number. So in my calculator, 188, 193. So let's put that in 188, 193. And let's go back and get our standard deviation, 2.593. 2.593. Okay, I get 0.8316. That's not making sense. Oh, my standard deviation. I want to be above 0.93. Oh, what am I saying? Okay, silly I am. And I got to change my standard deviation. I swap those, 0.2593. I'm saying it the wrong way, 2.593. Okay. So I get my answer 0.0269. 0.0269. So that's my probability that my sample will be greater than 193. Nice. Now, if I had a calculator, and we'll start working on this, I promise, norm CDF, I'd put my lower bound, I want the area under the curve from 193 to a really big number, and my mean is 188, and my standard deviation is that. And that's all you have to show on the test, and show your answer. Yay. Because 250 is less than the very large population of adult men. All right, thanks for joining me. See you next time.